finding real roots of polynomial equations. So what we're trying to do then is basically when we talk about finding roots, we're talking about solving when it equals to 0. So if we recall here, reminds us about the zero product property from lesson 5.3, which we kind of talked about that a little bit yesterday. You can find the roots or solutions of a polynomial equation, p of x equals 0, by setting each factor equal to 0 and solving for x. And we went back over and reviewed yesterday with finding zeros. And so today we're going to continue to do that, but we're going to look at actually, instead of using the zeros to write it in factored form, we're going to find the zeros. So we're going to use factoring to solve polynomial equations. So since they want us to solve by factoring, what's the first thing we're going to do here? Okay, see what they have in common. Right? And these all have 4 and x to the 4th, right? So when I factor, you get 4x to the 4th times the quantity x squared plus x minus 6. Can we factor x squared plus x minus 6? So we're going to have, just like what we were doing, our little practice problems we were doing from page 338. Right? What are the factors of negative 6 that add up to 1? Okay, positive 3 and negative 2. So we have x plus 3 and x minus 2. So we set those equal to 0. This is the zero product property, tells us to do this. If I'm multiplying 3 things together and they equal 0, then that means that either one, or at least one of them, has to be equal to 0 then. So if I solve this first equation, 4x to the 4th equals 0, what does x equal? It's 0, yeah. X just equals 0. Right? If x plus 3 equals 0, then what makes that equal to 0? Okay, negative 3. And x minus 2 equals 0, then x equals 2. Okay. What's that?
We're just adding a step, like we're like factoring and then we're
Right, yep. Yep. Yep, so basically just taking that factoring one more step and actually finding out what makes it equal to 0. Okay. Now when we're solving by factoring, the first thing that must be true is that we have to get everything on the same side of the equal sign because we want it to be equal to 0, not equal to something else. So my first step here then is going to be to subtract 26x squared. And then make sure you write it in standard form after you do that. Now, some people have a hard time with these factoring this kind just because it has x to the fourth and x squared there. Okay? Well, it's actually the same as factoring that x squared plus x minus 6. Okay? The only difference is that we're using x to the fourth and x squared. The point is that let's take a look at this x squared plus x minus 6. Okay? In this situation, we had x plus 3 and x minus 2. Now, if I write it as x to the fourth plus x squared minus 6, this is exactly the same factoring method. The only difference is that we've doubled the exponents. Okay? The thing we're looking for is, are these exponents always, is one twice what the other one is? Okay? So this one, if I had a 4 here and a 2 here, then we would have x squared plus 3 and x squared minus 2. Okay? If I went further, and I said, okay, well this is x to the 8th and x to the 4th minus 6. Okay? Then we're looking at these exponents. Is the one twice what the other one is? If it is, then the middle term determines the exponent in my factoring. Okay? So if I factor this, it would be x to the fourth plus 3 and x to the fourth minus 2. So what we're looking for is the degree of the first term double the degree of the middle term. Okay? If it is, then I can factor it just like there was a 2 and a 1 there. It's just that whatever the degree of the middle term is, that's what's going to be in my factors. So here, so what are the factors of 25 that add up to negative 26? Negative 25 and negative 1. So this will be x squared minus 25 and x squared minus 1. So it factors just like the simpler ones. It's just that my middle term then is going to be what determines the degree in my factors. So what do I do now? Okay, find the zeros. Okay. We actually have two options right now, okay? Because x squared minus 25 is, right, it's the difference of two squares. So we could still factor this one, and we could factor this one. So we actually have two different things we could do. We could factor it further, because then it would look obvious what they are. Or you could set each of them equal to 0 and solve them. So let's say we factored it. So we could say, so this would be x plus 5, x minus 5, x plus 1, x minus 1 equals 0. So then we would get negative 5, 5, negative 1, and 1 as our solution. And you could write that as plus or minus 1 and plus or minus 5. You could write your answer either way. Both of those solutions mean the same thing. Now, or the other thing you could have done is we could have said then that x squared minus 25 equals 0, or x squared minus 1 equals 0. And I want to go through this because there might be some problems where you can't factor those. Okay, x squared minus 25 might be a 7 there, for instance. Okay, and if you get to those situations, then we're not going to be able to factor it, so we're actually going to have to solve. So now I'll add 25, so that means that x squared equals 25, or x squared equals 1. Okay. And then what do I do? Okay, we take the square root. Now here's the thing to remember. When I take the square root, so I'm solving an equation, you have to remember that it's a plus or a minus. Okay, it's not just positive, it's positive or negative. Because negative 1 times negative 1 is 1, just like 1 times 1 is 1. Or negative 5 times negative 5 is 25, just like 5 squared is 25. Okay? Sometimes a polynomial equation has a factor that appears more than once. Okay? So for instance, we just had 4x to the fourth in that one example, didn't we? Okay? So there the factor x actually appears 4 times, okay, because of the x to the fourth. This creates what's called a multiple root. In example 1a in your book, 3x to the fifth plus 18x to the fourth plus 27x cubed equals 0 has two multiple roots of 0 and negative 3. For example, the root 0 is a factor 3 times because 3x to the third equals 0. And we just had one in that example we did that where we had 4x to the fourth, so we have the 0 is a factor 4 times because I could have written this as 4 times x, 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 and x. So we actually have that factor that happens 4 times. The multiplicity of root r is the number of times that x minus r is a factor of the polynomial. When a real root has even multiplicity, all right, this is an important part to, if it has even multiplicity, then it touches the x-axis, but does not cross it. When a real root has odd multiplicity greater than 1, the graph bends when it crosses the x-axis. So even multiplicity, it touches the x-axis but doesn't cross it. Okay? It looks like a quadratic. Okay? You know what a quadratic looks like, right? Okay? Either smiles or frowns, but when it gets the x-axis, it hits it and turns the other way. Goes back the other direction. Okay? If it's odd multiplicity greater than 1, it bends as it crosses through the x-axis. And if the multiplicity is 1, then it just crosses the x-axis. It just goes through it. Okay? All right, so here they show their example with 3x to the fifth plus 18x to the fourth plus 27x cubed. Here is the graph of it. So it shows that it says the root negative 3 has a multiplicity of 2, so the graph touches at negative 3, 0. So the graph goes up, hits the x-axis at negative 3, 0, comes back down. Okay. The root at 0 has a multiplicity of 3, so it bends there. Okay. So you can see how the graph kind of makes a little bend as it goes through the x-axis. We can't always determine the multiplicity of a root from a graph. It's easiest to determine multiplicity when the polynomial is in factored form. Right, so we're going to look at this thing called multiplicity. How many times is the factor, or is a factor a part of a polynomial? So we want to here's this example, x cubed plus 6x squared plus 12x plus 8 equals 0. We want to identify the roots of the equation and then state the multiplicity of each root. Now, if we can factor it, that would be awesome, okay? And so let's take a quick look at this and see if I can factor it. I've got 4 terms, so maybe I can factor this by grouping. Let's see. I have, take out x squared to get x plus 6, right? Over here, am I going to be able to get an x plus 6 over here? No. Okay, so I can't factor it by grouping. So we're going to use our wonderful piece of technology that we have, our wonderful calculator, and we're going to graph this function. So if you can't factor, then graph. And most of the time when we're doing this, you're always going to get whole number, or I should say integer zeros, so that you don't have to worry about fractions or decimals usually. When we're looking at multiplicity, usually we're dealing with whole numbers. So put in your y equals and graph it. Did I type that in right? No, I'm wondering. X cubed plus 6x squared plus 12x plus 8. Oh, there would be my problem. 88. There we go. Ah, much better. Okay. So how many places does this cross the x-axis? Hard to tell, isn't it? Okay. So let's zoom in. How can I zoom in on that a little bit better? Anybody know? Okay, you could do zoom box. Or there's also another one. If you do zoom decimal, it actually makes it, it's a smaller window. It goes from like -4 to 4. So let's try zoom decimal, number 4. All right, so how many zeros does it look like there is now? Okay. Looks like there might be 2 of them. Okay. All right, let's check out our table. So it's around -2, isn't it? Right. So let's go to -2. And there we have a 0 at -2, but there's no other zeros there. Okay. Now, so I have that 0 at -2, but what does it do there? It bends, right? Okay. And they just told us that if it bends, then the multiplicity if it bends, if we have odd multiplicity greater than 1, the graph bends as it crosses the x-axis. Okay. Well, if I have a 0 at -2, then I have my factor would be what? How do I take a 0 and write it as a factor? What do we do? So I'm going to have x here, and the degree is odd, greater than 1. So what goes inside the parentheses there? If my 0 is -2, this has to say x plus 2. Okay, thank you. Okay, all right, it's always the opposite, right? Opposite of what the 0 is. So I can check this then. So I'll go back to my y equals. And in my y2 then, I'm going to put x plus 2 to the 3rd power. And then I'm going to go to my tables. Now graphs are always nice to check to see if they're the same, but tables are much easier because it right away tells you whether the numbers are the same or not. In this case, the numbers are the same. So, what do we have here? They want us to identify the roots. Okay, so the roots here has one root at -2, and state the multiplicity of each root. So the root at -2 has multiplicity of 3. And that's because it bends when it goes through the x-axis. Now, here's the thing. Right? Notice this multiplicity number here. And we're going to look at somewhere, obviously, there's more than just one root. Okay? But all my multiplicities and this number here have to agree. Right? The degree of the function, or the polynomial, and the sum of all the multiplicities has to be the same. Now, I knew this couldn't be 5, right? Because the degree of the polynomial is only 3. It bends going through. If it ever just goes right through the x-axis, that means the multiplicity is 1. But like we said, if it touches it, then it has to be even. 2, 4, 6, 8, or whatever. All right, let's look at another one. Don't think we're going to be able to factor that one. Let's graph it. Go right to your y equals. Clear everything else out of there so it's not still there. And graph it. And then go back to your standard viewing window. And what we're going to do is we're going to make a little table to help us here. And we're going to tell what our zeros are, what the graph looks like, and then what the multiplicity is. The zeros, what the graph does at those zeros, or what it looks like at them, and then therefore what is the multiplicity going to be. Okay, so Thomas, what are our zeros in this case? If you need to go to your table to confirm them, go to your table and confirm them, then that's okay. Delete the graph. All right, here we go. We'll help you out then. Okay, what are they? Emily, what'd you get for the zeros? No idea. All right, Jasmine. Okay, -3 and 1. So we cross the x-axis at -3 here and at 1 there. Okay. We could confirm that by looking at our table. There's a 0 at -3 it equals 0, at +1 it equals 0. Okay. So what does the graph do at -3? Does it, we're looking at three different things. Does it go through or cross? Does it bend? Or does it just touch it and go the other way? Okay, at -3 it bends. All right, so that tells me that it's got to be odd and greater than 1. Okay, what happens at 1? What's the graph do? Okay, it crosses it, okay, or goes through the x-axis. Just crosses the x-axis. Okay, so if it just crosses, then the multiplicity has to be 1. It can't be anything more than that. If it just goes right straight through, it can only be 1. Okay? Because that behaves like a linear function. Okay? Linear models are just straight lines. So it just goes straight through. So then, here's the thing, is that if I do the total for all of these, the total for all of the multiplicities has to add up to 4, the degree of the polynomial. So then, since -3 it bends there, what's the multiplicity at -3 have to be? 3. Because these added together have to equal 4. Okay. Now, so let's look at what happens then is that I can write it in factored form. I now have the ability to factor this polynomial because it's now x plus 3, right? If I have 0 at -3, it's x plus 3. Since the multiplicity is 3, that's to the third power. And x minus 1. Since the multiplicity is 1, that's to the first power. So I've just factored that very ugly polynomial. Right? Let's verify that that's true. So if I go back to my y equals, and in y2, put x plus 3 to the third times x minus 1. And then I check my table. Okay. So we can really use our calculator to factor if we want to. Right? So here we have a graph that has a zeros at -3 and 1, and a multiplicity of 3 at -3 and 1 at +1. Um, I want you to do letter B then, on this check it out.